Good afternoon. Today we will start with lesson 2, which is talking about radical or simplifying radicals. The objective from this lesson is how to simplify radicals involving or including products and quotients. Now, radicals, this is square root of 36. This is cubic root of 8. Now, square root, cubic root, these are, we call them radicals. So radicals is an nth root of any number. Today, we will learn how can we simplify radicals. All of us know that the square root of 36 is 6. But what about the square root of 18? 18, it's not a perfect square. 36 is a perfect square. But 18 is not a perfect square. And if I'm asking you to simplify it, what we have to do? Shall we keep it as square root of 18? No. Today, we will learn how can we simplify the radicals. Now, the radicals expression, such as 2 square root of 3, so radical expression like 2 square root of 3. This is a radical expression. Or square root of x plus 3. Look at them here. Sometimes we can have a numbers like this. Sometimes we have a variable plus a number. But we must have a square root or cubic root. We must have a root. It contains a radicals. So radical expression is an expression that have a radical. This is an expression. But if we have an expression with radical, with root sign, we name it a radical sign, a radical expression. Now, a radical expression is simplified if the following statements are true. I can say that this radical expression is the simplified one. Where? If the radicand has no perfect square factor, like if you see square root of 9, this is not simplified one because square root of 9 is a 3. We know before that 1, 4, 9, 36, 25, 81, 49, and so on are perfect square numbers. So I cannot keep a number which is perfect square under the square root because it's not a simplified one. Because I can say that the square root of 49 is 7. This is a simplified one, but this is no. The second one, the radicand.
So teacher, the radical is. So teacher, the radical is, for example, root of 7.
Square root of 7. Now, the radicand contains no fraction, and no radicals appears in the denominator of the fraction. So I will say that this radical expression is simplified if there's no square root under the perfect square number. There's no square root. When I say square root of 49 and I will stop, this is not the simplified one. 2, it must have no fractions. The radicand contains no fractions like this or like this. This is not simplified one. The radicals must not contain a fraction. And also, no radicals appear in the denominator of the fraction. If you see it like this, if you see it like this, this is not the simplified one. So look at the simplified one here. You have 3 square root of 5. This is simplified one. Why? Look at number 5. Is number 5 a perfect square?
No.
No, Done.
No.
Did we have a square root? Did we have a fraction under the square root?
No.
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 Does the radical sign appears in the denominator?
No.
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 So this will
No.
be simplified one. Look at the second one here. We have 9. We have 9 square root of x. Look at it here. Look at the square root. I'm looking at the square root. Is there a perfect square under the square root?
Teacher, how square root under square root?
Perfect square number under the square root?
No.
No. So let's simplify.
No.
Is there a fraction under the square root?
No.
No.
Fraction.
Is the square root in the denominator?
No.
No.
Also no. So I say this is the simplified one. Look at the third one now here. Look at the number. I'm talking about the number that is under the square root. Look at the number under the square root. Is it a perfect square number?
Yes. No.
How yes?
No.
Did you remember what is the perfect square number?
Yes, that has two numbers that when you multiply them together give you that number.
Excellent, thank you. So like 1, 4, 9, 16, 25, 36, 49, 81, 64, 100. These numbers are a perfect square number. So is number 2 is a perfect square number?
No.
No.
No. So I will say that is the simplified one. Now, let's now continue here. 3 square root of 12. Is it simplified? Oh, before that, look at number 12. Number 12 here, you can tell me, teacher, it's not a perfect square. But if you factorize it here, how can you factorize 12? 3 and 4, is it right?
Yes.
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 Now look at number 4 here, one of its factors. This number here. Is it one from the perfect square numbers?
Yes. Yes.
Yes. So I will say this is not simplified one because there's a perfect square number under the square root. Look at the second one. Here. Look at the square root. Did we have a perfect square factor or perfect square number?
No.
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 2 is a prime number. I cannot factorize it. So no. Did we have a fraction under the square root?
Yes. Yes. 2.
Yes, there's a fraction. So because of that, I will say that this is not simplified one. What's the meaning of simplified? Simplified, like if you solve a problem and you stop here, I will say it is correct. But if you stop here, this is not correct. You have to simplify it. Now the last one, 5 over square root of 7. Look at the square root. Where's the square root? It is this one. What about the number here? Is it a perfect square number?
No.
No. Did it have a contain a fraction?
No.
No.
Is the square root or is the radical number in the denominator?
Yes.
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 So because of that, I will say this is not a simplified expression.
Teacher,
Yes.
when I say 3 square root 5 or 3 square root 12, what I mean? Yani 3 multiply square root of 5?
Yes, exactly. 3 square root of 5. That's mean 3 multiplied by square root of 5.
Okay.
Now, let's talk about their properties of the square root. Now, you can simplify radical expressions using multiplication and division properties of square root. For the square root, it has two properties, multiplication and division. We can simplify the radical expression using the multiplication and using the division. Today, we will talk about how can we simplify the square root using the multiplication. Let's see how here. The first one, you have to know that if you have a square root of a times b, any two numbers that are multiplied, okay, you can distribute the square root of both numbers on a and on b. So the distributive property here, did you remember in chapter 7 when I told you that if you have 3 times 4 to the power half, we said that this half will be distributed on the 3 and on 4. I can write it as 3 to the power half times 4 to the power half. Is it right?
Yes.
Did you remember that in
Yes.
chapter 7? If we have
Yes.
two numbers that are
Yes.
multiplied to the power half, I can distribute the exponents. Here also, in the square root, we have to do the same. If there's a square root of two numbers that are multiplied, I can distribute the square root on the first number and on the second number. Only if the two numbers are multiplied or divide. But if the two numbers are added, I cannot distribute the square root. Is it clear?
Yes, teacher.
So only if the two numbers are multiplied or divide, I can distribute the square root. If they are added or if they are subtracted, I cannot. Let's have an example now. Now let's see here, how can we find the square root of 48? Now, to simplify it, what we have to do? I will factorize number 48, but I will ask myself, I will write here first the perfect square numbers. I know that we have 1, 4, 9, 16, 25, 36, 49, and so on. I will write them here. Then after that, I will ask myself, give me number that if I multiply it by any of these perfect square numbers, this one of these numbers, multiply it by any number, I get 48. You will tell me, teacher, it is 16. 16. If I multiply 16 by 3, I get 48. So I must search about one of these perfect square numbers. Then I divide the 48 into this perfect square number, I get to 3. So if I multiply 16, which is a perfect square number, by 3, I get 48. Then under square root. Then, as we said before, let's distribute the square root into the 16 and into the 3. Now then, let's write it here, sorry, first. So let's distribute it now into 16 and the 3. I will put the two numbers here and here. Now, what is the square root of 16?
4. 4 multiplied by 4.
So I will put 4. Times square root of 3. So 4 square root of 3 is a square root of 48. Did you see now how can you solve it without calculator? You are the calculator now.
Okay.
Okay?
Okay.
Yeah. Let's have another example.
Okay, thank you, teacher.
You are welcome. Now let's have another example to understand it more. Let's see here what is the simplified form of 160. Now, before simplify, I will write here the perfect square numbers 1, 4, 9, 16, 25, 36, 49, 64, and so on. Now, I want you to think here to try to search one from these numbers, from the perfect square numbers. If you multiply them by any another number, you get 160. And I
16.
want to factorize it into number, any number, multiply by a perfect square number. I want to write it as a multiplication of perfect square number times any number. This is what I mean. So what did you want? You want it is 16, yes. 16 times
10.
times 10, exactly. It is 16 times 10. Then after that.
But teacher, 10 doesn't have a square root.
Sorry?
But 10 can't have a square root.
Yeah, wait. 10 have square root?
No, it does not have.
Oh, yes. I will continue now. So by now, I write as 16 times 10. Then I will distribute the square root in both numbers. I have 16, I will write it here. And I have the 10, I will write it here. Okay?
Okay.
Then, what is the square root of 16?
4.
4.
4.
And the square root of 10? There's no. So I will simplify it as 4 square roots of 10.
Can it be like that?
Sorry?
Can it stay as it is?
Yes, keep it as 4 square root of 10. This is a simplified one. Is it clear now?
Yes.
Yeah. Yes, teacher.
Teacher, it's a little bit confusing.
And inshallah, another example you will understand.
More? Yeah, examples.
Yeah, let's do now this one here. Square root of 72. I want to find the square root of 72. Now, yalla Dana. 72. I want you to look at the green table here. Give me any square root number. And if or another example, in other words, I want you to factorize 72. Okay, to write 2 factors of 72. One of them must be a square, perfect square. If you want to simplify or to factorize 72, you can say it is 8 times 9. Is it right?
Yes.
You can say also it is 36 times 2. You can say also it is 6 times, let's take 6 and 6 times 12. And what also here? We can say it is 18 times 4. Is it right? All of these are factors of 72. Is it right?
Yes.
Yes, teacher.
Okay, then the second step, after you factorize them, give me one. Here I have 8 numbers. Give me which one is is a perfect square numbers? Which one is from this green table? Is 8 from this table? From
No.
here?
No, but
Look at this
No,
table
no.
here. No. 9.
yes.
Yes.
Yes. So I will say that it is 8 times 9. So let's say it
Yes.
as 8 times 9. Okay. If you see it like this now, you will say that what is the square root of now? Let's now simplify it as square root of 8 times square root of 9. Now, square root of 9 is what? 3.
3.
Now look at square root of 8. Is 8 contain any perfect square number multiplied by a number?
Yes.
Okay.
Yes, 4.
See, I will describe it for you in other words. If you look at number 8, is 8 is a prime or composite number?
Prime. I mean composite.
Composite. So if it is composite, I cannot say this is the simplified one, because I can write it as square root of 4 times 2. Then I will simplify it more and more. So I want you later on, I will show you how, but I want you now to look at them to give me a prime number. Okay, I will write it here as a prime number times perfect square.
and 2.
So if you look at, yeah, keep it here. 18 is not a perfect square, so cannot you choose this one. 12 and 6, is there any one from them is a perfect square?
No.
No.
12 and 6. No.
No, exactly. So no. But if you look here, we have a 36 and 2. One is a prime and one is perfect square number.
Perfect
36
square, yeah.
and 2.
26.
So I will choose now 36 and 2. This is the first step. I choose a perfect square number from this table times any prime number. Then now after that, sometimes maybe, or خلاص, keep it later on, I will talk about it. Now after that, I will write this square root. Since I have 2 numbers, so I must write 2 square root. Then after that, I will take this 36, I will write it here, and I will take this 2 and I will write it here, and take this multiplication down. Then after that, what is the square root of 36? It is 6.
6.
And O times square root of 2. This will be the simplified one. Now, let's see what happens if we take 8 times 9.
Teacher, why 9 and 8 didn't work? But 9 is a perfect square that...
But wait, I will tell you. See here. 9 times 8. 9 times 8, I can write it as square root of 9 times square root of 8. Is it right?
Yes.
Okay. Then after that, look at number 9. It's a 3. The square root of 9, sorry, is a 3. But I told you that, and for the simplified one, we must have a perfect square. There's no perfect square factor. What does it mean? That's me. Can you simplify or can you factorize 8? Or is 8 a prime number?
No.
No. Give me 2 numbers. If you multiply them, you get 8. One of them is a perfect square.
4 and 2.
4 and 2.
2 and
Is
4.
it right? 4 and 2. Then let's continue here. We have 4 and we have 2. Then square root of 4 is what?
2.
2.
Square root of 2. And don't forget this 3. What the answer? 6. Sorry, here we have 2. Now, 3 times 2 is 6, square root of 2. That's we get the same answer. So we can solve this one, and we can use 36 times 2, but 36 times 2 is the easiest one.
Teacher, I have a question. In the previous one about 4 and 10, the answer was 4 and square root of 10. 4 can be simplified more to 2, or just stop here.
4, it was, okay, wait. What I have to do? Sorry, Sarah, before that, do you have any question here? Before I clear?
I know.
No, thank
Okay.
you, teacher.
You are welcome. Now 6 square root of 10. How can you simplify it more? You keep it as like this?
Yes.
Okay, you keep it as 5 times 2. Then square root of 5 times square root of 2. What is the square root of 5?
There is no square root of 5.
No. What is the square root of 2?
There is also no square root of 2.
No square root of 2. So because of that, this is the simplified one. Because if you factorize it, you cannot make anything. Is it clear now? Yes, Sarah, is it clear now?
So teacher, here the answer would be square root of 5 and square root of 2?
No. This is not the answer. I'll show you that if you factorize 10, you didn't make anything extra. You didn't make anything. Keep it as 6 square root of 10.
Okay.
Okay. Yeah. Let's now simplify each radical expression. Let's start now with number 10 here. Square root of 225. Now, think about it. Give me two numbers or factorize 225. Give me two numbers. If you multiply them, you get 225. Let's write here the perfect square numbers. 1, 4, 9, 16. 4 by 4 is 16. 5 by 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64.
54.
9 times 9,
81.
81. 10 times 10,
100.
100.
100.
11 times 11,
111.
no,
11.
121. 12 times 12,
144.
144. 13 times 13, 169.
169.
14 times 14, 196. 15 times 15,
225.
225. So, what is the square root of 225 will be?
15 and
15.
15.
Only 15.
15 and 15.
So, this is easier one. Is it right?
yes,
Yes.
sir.
Yes.
Okay. Let's now to go to
Yes.
number 11 here.
Teacher, I had a question for the previous one, 6 and 10.
Yes.
You said something I didn't understand it. Yani, you made the square root of 5 and the square root of
2.
yes, 5 and 2. While you are solved it, you said it cannot be solved or what?
Yeah, no. I mean that there's no square root of 5 and there's no square root of 2.
Yes.
So that's why I have to stop at 6 square root of 10.
Okay.
And you must stop at a number which is not have any perfect square numbers, or which is not a perfect square number, or which is not can be factorized to a perfect square number.
Okay, miss.
Okay, now look at number 11 here. In number 11, I want 99. Now, I want you to give me a number that's one of them is perfect square times a prime number. Who can give me? Yes, Nada. 99. Give me perfect square number. If you multiply it by a prime number, you get 99.
Okay,
Can I,
teacher.
teacher?
I will think.
Nada. Is Nada here?
Teacher, there is no one.
Can I, teacher, please?
There's no. Okay, Sarah.
9 and 11.
9 and 11. Thank you. Look at number 9 here. If you multiply 9 times 11, you get 99. Let's continue now. Let's distribute it. Then square root of 9 is
3.
3. And square root of 11, it's
There's no.
there's no. So I will say it's a 3 square root of 11. Clear? Is it clear?
Yes, miss.
Okay.
Yes, miss. So 9 and 11, yes, okay, teacher. Yes.
Now number 14. In number 14 here, we have a negative 4 square root of 117. Okay. I want you now, negative 4, you write, keep it outside. I don't want to factorize it. I only factorize the number which is under the square root, which is 117. Okay, I have to factorize only the number under the square root. Yeah, 117. Give me two numbers. If you multiply them, you get 117. One of them is a perfect square number.
Teacher, this is number 14.
Number 14, yes.
Yes,
Now, I
negative
want
4,
you
okay.
to come back to grade 6. Did you remember, if you look, how did you know that? If you look at any number, how can you know if it's divisor by 3 or if it's can divide by 5? Did you remember this? Or it's divided by 9? Do you remember these things?
Divisible.
If the number starts by 0 and 5, it will be divisible by 5. If it starts with 0, it can be divided by 10.
Yeah,
Yes, I
If the
remember.
summation, if it starts with even number, it can be divided by 2. If it's the summation of the numbers are 3 or can divide by 3, Oh yeah, I mean like give me
Teacher, I remember something about 3. If you add the two number, for example, 99, if you added them and they and the sum is a multiple of 3, then it can be divisible by 3.
Right, exactly. And this has happened for 9 also. If the number can be divided by 3, it will happen by 9, divided by 9. So look at number 100. I give you these things to just to make it easier for you. How can we get, or how can we factorize 117? Let's use this tree here. 117. Can I look at it here? 7 or 117. Okay, 7 plus 1. 8 plus 1.
7.
9. Can I divide by 3?
Again, teacher?
Teacher again?
Okay, 117. It is 3. Sorry, 7 plus 1.
8.
8 plus 1.
9.
9. So 9 is a multiple of 3. Is it right?
Yes.
Yes.
So it can be divided by 3. Is it right?